Hello everyone, let's solve a roller coaster problem. Okay, a roller coaster vehicle has a mass of 500 kilograms when fully loaded with passenger. If the vehicle has a speed of 20 meters per second at point A, what's the force of the track on the vehicle at this point? Let's write down given information. We have a mass of 500 kilograms and speed. We have the radius and we are looking for the force of the track on the vehicle. In other words, we are looking for the normal force. This is known as apparent weight. So anytime you see the question asking you to find the apparent weight of the circular motion, you know you have to find the normal force. Okay, so let's write down M equals 500 kilogram. 500 kilogram. We have the velocity 20 meters per second along the track, and we have our radius 10 meters, and we have to find the normal force. Then we can use the Newton's second law. Before that, let's draw our force body diagram. Okay, here's the center of our circle. And we have a radius 10 meters. And at point A, when these people pass along at that instant, there will be a normal force toward the center. It's going to be upwards. In other words, it will be perpendicular to the surface of our track. And there will be force of weight acting downward. And also, there will be centripetal acceleration toward the center. So I'm gonna say FC equals MAC. I'm gonna call that plus. Then this will be plus and there will be minus. Make sure the sign notation is consistent. If I happen to say minus here, and that has to be minus, and because this is acting opposite direction, it will have to be plus. But I'm gonna say plus here, so let's keep this consistently. Okay, and let's write down the equation. Okay, I already wrote that. So N minus mg and a centripetal acceleration. I can rewrite that as, because you do know this is the right formula. So I'm gonna put that in here. The reason is we are given the tangential velocity, and we can plug it in. We do know the radius of this circle A. Put that there. So it's gonna be like this. Okay, n minus mg. What are we looking for? We are looking for the normal force. Okay, it's always good to remember what our goal is. So I circled that. I'm looking for that. Let's quickly check the variables. Do we have mass? Yes, we do. The g is just the gravity constant, so 9.8 meters per second squared, and we have the mass again. And then our tangential velocity, 20 meters per second, and we have our radius. Alright, so we just have to find n. Everything else is given. Add mg on both sides. Then we have, you see how this cancel out. Okay, n equal n v squared over radius plus mg. We can factor out the mass. Plug in the numbers. And when you punch in your calculator, you're gonna get 500. Okay, let me write this again. You're gonna get something like this, 49.8. Then we get 24.9 times 10 to the 4th Newton. I'm gonna get 2 sig fig because I know some teachers don't care sig fig, especially in physics, but it's good practice. I know in chemistry this will be 1 sig fig and there will be 1 sig fig. But normally we don't ask for 1 sig fig because that's very unrealistic. I'm gonna keep 2 sig fig. Your teacher should be able to accept 3 sig fig as well because this is 3 sig fig. So, alright, 2.5 times 10 to the 4th Newton. I'm gonna box our answer. Well, we just answered A, now let's try B. What's the maximum speed? This is what we're looking for. Vt. The vehicle can have at point B for gravity to hold it on the track. This is another way of saying n equals 0. Okay. When the normal force acts 0 here, in other words, it matches with the weight of the vehicle, then the people here will feel weightless. Okay? But they will still undergo the circular motion. In other words, they are still in the track. Alright. So let's draw our fourth body diagram. Okay. This is our point B. Normal force, because this is our track, it's perpendicular to it. And then we have force of gravity acting downward. And don't forget our center is here, unlike A. And then we do know centripetal force will be this way, toward the center. Again, this is a one-dimensional problem. Only y direction is relevant to our problem. So I'm gonna say this is FC, or you can say AC. I'm gonna set the plus. You can put minus if you want, but make sure you're consistent. If you put minus here, that has to be minus and that will be plus. Since I call this plus, I'm gonna call that plus, and I'm gonna set the minus. Use Newton's second law. mg minus n mvt squared over r. What are we looking for again? We're looking for vt. So I'm going to circle that. Alright, do we have mass? Yes, it's 500 kilogram. Gravity, we do know. So it's 9.8 meter per second squared. Normal force, we call that 0 according to the problem. And then, let me rewrite that. So this goes 0. Oh, I forgot B. Don't put A here because we're looking for the point B. Has a radius of 15 meter. So we have everything except VT. The rest is just algebra. Okay. You do notice that mass can cancel out, right? Okay, let me rewrite that. Okay. Mass can cancel out. I can multiply radius on both sides. Vt squared equal, okay, I want to know the maximum velocity. Square root both sides. Notice our unit cancel out neatly. Meter times meter, you get meter squared. But when you square root meter squared over square second squared, you get meter per second. And when you punch this in your calculator, you're supposed to get 147 inside under our radical sign. And you're gonna get 12.1. And again, I'm gonna keep 2 sig fig. So our answer is this, 12 meters per second. In other words, if we go beyond that speed, say we go like 13 meters per second at point B, what happens is this vehicle is not going to be no longer in the track. Okay? Anything under it, like say 11 meters per second, or even 11.9 meters per second, the people here will not feel much weight, but they are still in the circular track. Okay? Alright, that's it. Thanks for watching, guys.